Solid A reacts with strong NaOH, liberating a foul-smelling gas B, which spontaneously burnt in air, giving smoky rings. A and B are what? The question here. A and B are what is the question? Okay. So we know one thing. Phosphine, correct? That is nothing but what? pH 3. Yes, pH 3 has a rotten smell. Okay, pH 3 has a, that is phosphine. First thing here I write is the phosphine here. The phosphine is my pH 3 has got what? A rotten egg smell actually. A rotten egg or rotten vegetable or whatever it is. It has got a rotten smell. So that is my first thing. Yes. Now the question is what? It's not about phosphine, but see the question. Solid air reacts with NaOH, liberating foul smelling gas B. So gas B is what? Phosphine. You got the point. So we can directly eliminate what? Option C and option D we can eliminate. Then it can be either option A and option B. P red and PB. Okay, P red and PB. But what is this P red and what is this PB? Can anyone tell me that actually? My question is very simple. We got something called P red and P white. Two, I can say this is red phosphorus, this is white phosphorus. What is this actually? These are nothing but what? The allotropes. Correct? These are nothing but what? The red and the white is nothing but allotropes of phosphorus. First thing. So these are nothing but allotropes of phosphorus. But if you want to know what is difference in the sense, white phosphorus is poisonous. This is poisonous, and this gives what? Yes. So this is the compound which reacts with what? Strong NaOH. Yes, it's not the red. Both are P4 anyway. Both are P4 only. But the thing is what? White phosphorus reacts with NaOH. Okay. Yes, it gives a rotten smelling gas. That is B. That is my phosphine respectively. So it is always the white phosphorus. So, but important thing is that we have to know the difference between the two. You got the point. White phosphorus. And one more thing here we can see a very important thing. The most important thing is spontaneously here. I'll write. Only white phosphorus reacts spontaneously. White phosphorus reacts spontaneously. We should know the difference in this. What about red phosphorus? Red phosphorus is less reactive. Red phosphorus is less reactive. So in the sense, we should know the properties of these elements. If you're studying the P block, yes, especially from group 15 to group 18, correct, we have to know each and every element physical properties too. Maybe the allotropes also we have to know. The key word in this is the red and the white phosphorus thing. Is it clear to everyone why we are using white and red? The keyword here is spontaneously is the keyword. Correct? White phosphorus, what? What does white phosphorus do? It undergoes spontaneous combustion in air. White phosphorus undergo spontaneous combustion in air. Yes, and the rotten smell thing is phosphine. So that's how we get the answer. Fine. Any doubt to anyone? So again, if there is any confusion is there, we'll just write the reaction itself. Okay, if there is any confusion in this, better to write the entire reaction. Then only will come to me. I'm writing P4. I'm not writing red or white. Okay, that I don't want to write now because you know what it is. Okay, so P4, white phosphorus. Because some of you may have confusion why cannot be H2S also. Correct? And sodium hydroxide, NaOH. Will give me what? Plus water, obviously the water is there in this. Plus water will give me what actually? Phosphine or H2S. But I'm not talking about that. But what are the other compound? It is nothing but NaH2PO2. What is this compound called? So this compound is called sodium hypophosphate. NaH2PO2 is called what? Sodium hypophosphate. How many of you are hearing this for the first time? So Na is removed, H2 okay, that is also removed. Fine, PO2, phosphorus okay, but we need what? P4, 4 phosphorus is required. Correct? Yes. And sodium hydroxide, NaOH is there. So if you are balancing everything, then I have to do balancing here. 3 and what here? 3. And here also then it will be 3. 3 sodium in the sense. Then I got what is left here. Then I got what is left. 3 hydrogen is left because again 3H2 is used. So 3 hydrogen is left. Correct? H3. Then what is it? Only one thing is remaining is P. Because already I used this thing. So this is the general reaction for this. Sodium hypophosphate respectively. So guys, the spelling for this is hyperphosphite. PHITE. Okay. It's not phosphate, phosphite. Sodium hypophosphite. PHITE. The ending letter is ite. Okay, fine. And these are all acids. These are all acids respectively. That's how we get pH 3. So you can just copy down this reaction too. So we know the compound. This is what? White phosphate. Correct? White phosphorus. This is my white phosphorus and phosphine. White phosphorus and phosphine respectively. So the learning from this is each and every element properties we have to know. That's it. So this question SO2 plus H2S is giving 3S plus 2H2O. This equation represents preparation sulfur solved by what? Correct? Yes. So here we can see sulfur dioxide. Correct? It is reduced to what? It is reduced to sulfur. Correct? But what about the sulfur atom in this thing? What about H2O? What is happening? What about the sulfur atom in hydrogen sulfide? What is happening to the thing? That is getting oxidized, right? This one is getting oxidized. Everyone agree or not? See, first thing in this, I have to tell you this question. Okay, sulfur in sulfur dioxide is getting to reduce to sulfur. Correct? And sulfur atom in H2S, what is happening? What is getting added with H2? It is getting oxidized, right? So SO2 is reduced to sulfur. I'll write on words. SO2 is reduced to sulfur. Correct. Next one is what? H2S. That is oxidized to sulfur. Correct? So what kind of reaction is this? This should be a redox reaction. See, the question is very simple in this. If I want to just erase these things, wait, let me erase everything in this. Yeah, let me erase. See, what is happening this is very simple thing. Correct? SO2 is reduced to sulfur and H2X is oxidized to what? Sulfur thing. Here one is getting oxidized, right? Yes, in H2 is what is happening. You got the point. So this represents both oxidation and reduction. So sometimes the question may also be wrong. You get the marks for that. So this is a redox reaction. So I cannot directly go to the thing in this. This is a redox. Sometimes it happens during the entrance exam. Sometimes the question or the answer may be wrong. You'll get the marks if you attempt. Either B or C if you mark, then only you'll get correctly. Okay, if you mark A or D, you won't get it correct. Is it clear to everyone? Is this thing clear? It's a redox reaction. Both reduction and oxidation happens in this. Yeah. Third question. Coming to the third question, which of the following inert gas compound is not formed? So I got most of your answers as option D. Okay. But the most important thing for us is to know the correct reason for the right answer. NeF2, okay, doesn't exist at all. Why? Because the sum of the first ionization enthalpy, correct? Or else again first and second ionization enthalpy. Sum of first and second ionization enthalpy is very higher or very greater than that of the ionization enthalpy of xenon. Correct? And moreover, if I take fluorine here, yes, this fluorine or F2 can oxidize Xc to Xc2 plus. Xc2 what? Xc2 plus, but not Ne. This fluorine cannot oxidize what? Cannot oxidize Ne to Ne2 plus. Xenon can oxidize, but not that of neon. So that is the reason this doesn't NeF2 doesn't exist. So better to understand each and everything in large. That's all. So this is the answer for the question. Yeah. Nitrogen shows maximum covalency of 4, whereas heavier elements of the group shows higher covalency because one thing is high electronegativity, okay, smaller size. This anyway cannot be. It has smaller size, it can be. Last one is it prefers to form multiple bond with electron. This also we cannot say. Option C, it has only 4 orbitals available in the valence shell. Okay. Why it is restricted to 4 orbital? That we have to know because of the absence of what? Because of the absence of d orbitals. Because of the absence of d orbitals, this has been reduced. Correct? So what is the 4 orbital? 1 2s and 3 2p. What is this 4 orbital? 1 2s and 3 2p respectively. So correct option is option C. Fourth one, option C is the correct answer. Absence of d orbital. Yes. If you want to know what is 4 orbital, we have to know the electronic configuration. Okay.